Right. Is my screen is visible to you?
Yes, ma'am.
Okay. So today, yesterday, mainly we studied about the variations, why the variations is important, and what are the measures we can use to measure the variation. Mainly, we looked at range and also the variance and the standard deviation. Why we are taking the standard deviation rather than considering the variance to measure the variations of the data, right? As a continuations of yesterday's lecture, today another measure we are looking at the coefficient of variation, right? This is also one type of, we are measuring the standard deviation, but we are measuring the standard deviation in relation to mean. With respective to mean, how much of deviation is there? So for 1 unit of mean, how much of variation or how much of standard deviation is there? So it is always, we are looking at this measure in the percentage. And also, why here we need such kind of measure? Because here also we are measuring the standard deviation, right? But why this for 1 unit of mean, why we are looking at the standard deviations, right? Mainly, this coefficient of variation is focused for comparing the two different data sets, right? So in what situations we have to use this measure to compare the two different data sets? They are measured in the different units, such as, for example, one is in the kilogram and one is in the centimeter, right? Such kind of difference in the unit of measurements. And also, even the same unit of measurements we are having, but the mean will be different, right? So to make the similar comparisons, we are making it as a 1 unit of mean. So when we are dividing the standard deviation by the mean, actually the units cancelled. So it is also unitless. So whatever measures we are using, the unit measurements we are using to measure the original data. So when we are taking the coefficient of variation, this measure does not have unit, right? So that problem will be eliminated. Similarly, even if we want to compare the standard deviation, actually the mean should be same. Otherwise, it will give the different perspective, right? Because for the larger mean, we have another result. For the smaller mean, we have a different result. So to ignore the differences in the means, the coefficient of variations will help us. So mainly for comparison, and also when the data are measured in the different units and with a different scale of means. So in that case, we are using the coefficient of variation. Right. Now here we are looking at the stock related variations, right? So here you were given that there are two different stocks related informations we are having. One is a stock A. For the stock A, the average price was given as $50 and the standard deviation is $5, right? The stock B, same for the last year, the average price is $100, but the standard deviation also $5. So in both cases, the standard deviations are same, but the average prices are different. So now we want to look at what about the variations among the stock A and the stock B, which shows more variations. Whether stock A or stock B shows more variations. So actually, to measure the variation, we are using the standard deviations. But in this case, both standard deviations are same. The units also same. both are measured in the dollars, right? So how then we can compare the variations between the two? What stock has more much of variations among the prices? How we can do it? So in that case, we have to definitely apply the coefficient of variation. So now we want to look at to 1 unit of mean, how much of variations among the stock prices A and among the stock prices B, right? So first we are calculating the coefficient of variations that is given by S over X bar into 100. So when we are multiplying by 100, it is a percentage. That is 10 percentage of variations among the data for the stock A with the prices. For stock B, that is also similarly we are calculating 5 over 100 into 100. That's 5% of variations among the prices. So when we are comparing which stock has more variations, stock A has more variations and stock B has less variations relative to its prices, right? So here both stocks have the same standard deviation, even though stock B is less variable or less variations relative to its prices. So actually, if you want to invest or if you want to choose to make some investment on both stock A or stock B, then which will be your answer? Which stock you will choose to make the investment? Put in the chat box. Using these results, which stock you will choose for investment purpose? Now, looking at these variations, right? Which stock you will choose? Looking at the average prices of stocks and the variations of stocks, which one you will choose for the investment purpose? Put your answer in the chat box. Then only we can make further discussion. Right. Now, in the other way around, I am asking, looking at the average prices of the stocks, which one here you choose? Stock A or stock B? Just look at the average prices. Then which one you will choose? Please put your answer in the chat box. Can you hear my voice or not? Students? Now, if you are not answering my question, right, this section I will leave it as reference. Com 115. Unmute your mic. Com 115. Where is the class rep? Right. Z-scores. This is a measure of the distance from the mean. Z-score, here we are measuring. This is already you familiar with your A-level results. So how we are measuring the Z-score? So to converting, this one will important for your next chapter, chapter 3, probability and distributions. Right? So this is a measure of distance from the mean. That a value, here we have to identify the corresponding X value. What will be the Z-score? We need the mean of all the X values and the corresponding standard deviation. Right? So this is also one of the variation we are calculating. It is a difference between the mean value and divided by the standard deviation. Usually the Z-score we will consider, we can calculate the Z-scores to looking at whether the informations are, some of the values are outliers or not. If your Z-score will be above 3 or below -3, then that will be considered as an outlier. And also, this is also, we are making the relative to the mean value. For one standard deviation, how much of your score is deviated from mean? For one standard deviation, how much of value is deviated from the mean value? Right? That is the Z-score. So here, for example, we are there is a mean value 14 and the standard deviation is 3, right? So what is the Z-score for the value 18.5? So that is Z is equal to 18.5 minus 14 divided by 3, that is 1.5. So actually, what is the interpretation of this 1.5? In the value of 18.5, right? Now we are looking at this value, 18.5 is 1.5 standard deviations above the mean. From the mean, it is larger than the 1.5 standard deviation. Mean plus 1.5 standard deviation. X is equal to mean value plus 1.5 standard deviation. If it is a negative value, then it is a mean minus this 1.5 into standard deviation, right? Right. Now we are looking at how we can calculate the variance and standard deviation for a frequency distribution. Here also we are considering two cases, ungrouped and the grouped frequency distribution, right? So all these formulas you have to know that variance for ungrouped frequency distribution is calculated by S squared. That is, we are multiply the squared deviations from the mean by the corresponding frequency. That is divided by n minus 1. The computational formula for calculate the standard deviations for the ungrouped frequency distribution or the variance for ungrouped frequency distribution, rather than using this formula, we have to use this one, right? So that is 1 over n minus 1, when we are simplifying, that is summation of fi into xi squared minus n into x bar squared. So here n is equal to summation of fi and x bar is equal to summation of fi into xi divided by fi. Right? So now this is the example here we are considering. Already this example we apply to calculate the mean value. So here for the same example, we are going to apply for calculating this is a ungrouped frequency distribution. Right? So here the table shows how much of desktop we solved, and for each and every number, how many times solved out of 30 days. So first we have to calculate the mean value because that's need to calculate the variance. So we are calculating the mean value by using this formula. So when we are adding these values, fi into xi, this is xi, this is fi, to multiply these figures and add all these figures, the total of this column gives a summation of fi into xi, that is 78. And the total number of observations for this one we can get by adding these frequencies, that is 32.6. So per day on average, 2.6 desktops are solved in a day. Right? Then variance. So to what extent these sales are deviated from the mean values. Now we are going to summarize these 30 observations by this x bar 2.6. So if we want to get how these other values are clustered around the mean value, we need the variance and the standard deviation. So to get the standard deviation, first we have to calculate the variance. So the variance, actually, this is the computational formula we applied here. So summation of fi xi squared minus n into x bar squared, 1 over n minus 1, that is 29, n minus 1. Then fi into xi squared. So here already you got fi into xi. To find out fi into xi squared, again this term multiplied by one more time fi. So 0 into 1, 0. Then 2 into 2 with the frequency. Sorry, it will be 4. You make the corrections. It will be 4. Then 20 into sorry, that is correct. Right. fi into xi, then fi into xi squared. So this fi into xi column should be multiplied by again xi. Right. So 0 into 0, 0. Then 1 into 2, 2. Then 2 into 20, 40. 3 into 36, 108. 4 into 20, 80. Right. After finding the fi into xi, again, you have to multiply each and every figure by the corresponding xi value. Right. So then if we apply that total 230 minus n, that is 30, into x bar squared. X bar you already calculated 2.6. So 2.6 squared. When you are simplifying, this one is 0.94. Now we need s, that is 0.97. By taking the square root for the variance, then you will get the value as 0.97. Then how we can interpret this one? Already in the raw data, we learned how we can interpret this one. Similarly, here also, we have to interpret the standard deviations. When you are interpreting the mean or standard deviations, you have to relate your problem. Otherwise, the interpretations are wrong. The common general interpretation you cannot write. What are the problem terms here we are using? That's you have to interpret it. So here the how the computers desktops are solved, the numbers, right? So here also we can say that the number of computers solved are are clustered around the mean. The number of computers solved are clustered around the mean by 0.97. Right? The clustered around the mean by 0.97. That means the computers solved, the number of computers solved are in between 2.6 minus 0.97 and 2.6 plus 0.97. Such kind of interpretation, you have to write it. Already for one examples, I wrote that how we have to write it. The similar pattern here also you have to follow it. Right. Now, if your group frequency distribution, then how we can calculate the variance. This is also approximated variance for a group frequency distribution. But here, like as a mean, what is the assumption we made? All the data fall within the particular class interval is considered as same as the midpoint of the particular class interval, right? So such kind of assumptions here also we are making. Assume that all values within each class interval are located at the midpoint of the class. So this will be the approximations because we are not considering the original values. For each and every class interval, if there are 5 observations in the first class interval, then we are assuming that each and every observations in the particular interval is same as the midpoint of that class interval. So definitely this will be the approximation variance for a group frequency distribution, which is calculated by this formula. The same formula as ungrouped frequency distribution, but here the xi, for the ungrouped, the xi's are no, we have to know the exact value. But for the grouped, we have to take the midpoint, right? But when we are taking the computational formula, the same computational formula is here also, but xi is denoted by the midpoint of a particular class interval. Then n is equal to summation of fi. And xi is the midpoint of the ith class interval, right? Right. This is also the example to calculate the mean value. We considered for the grouped frequency. Uh, 0 to 50 number of batteries, how much lifetime is the variable, and these are the class intervals form lifetimes, and these are the number of batteries given, right? So find the variance and the standard deviation, right? And interpret the standard deviations of lifetime of batteries, right? So here the example was done to you. So fi xi and fi xi squared. And first we are calculating the mean lifespan of the batteries, right? By using this one, then variance we are calculating, and then we are taking the standard deviation of lifespan of the batteries, 52.7. In the interpretation part, I'm leaving it as your homework, right? You practice how to make the interpretation for this example. Right. The last section of this one, shape. The shape is the pattern of the distribution of values from the lowest to the highest value, right? So here we are looking at how the data values are distributed from the lowest value to the highest value. That describes by the shape, right? So already in the graphical chapters, we learned the shapes we can looking at whether it is a symmetrical distribution or skewed distribution, right? Then if it is a symmetrical, if it's a one mode or more than one mode, right? Such kind of pattern we can observe. One is the whether it's a bell shaped or symmetrical. Then if it's a one mode or bi-mode or more than multimodal, right? So these are the things we are looking at for the shape. Already we looking at by looking at the mean and median, by comparing the mean and median, we can identify whether it is a left skewed or symmetrical or right skewed, right? If the mean less than median, then it is a left skewed. That means negative skewed distribution. If the mean and median both are same, then it is a here we are looking at this one. Here mean is comparing to median. Here mean is less. In this case, it's a right thing, right? Greater, right? Then it is a right skewed. Here it is a left. Then mean and both median same. It is a symmetrical. So here, two measures I am leaving as for calculating the two measures, right? You have to look at your reading material uploaded in the section and also note the measures, skewness, by using the mean, median and the mode, how we can calculate the skewness and how we can calculate the kurtosis and their interpretations. Those two measures I am leaving as a reference, right? So you have to find out what are the measures we can use to calculate the numerical summary measures as a skewness and the kurtosis, and how we can interpret those measures. These two measures are the references. Definitely you will have those questions, right? How we can interpret the coefficient of variations. What are the measures we can use to calculate the skewness, coefficient of skewness and the coefficient of kurtosis? You have to find out. This continuous assessment first exam, you will have some questions on it, right? Then for the numerical measures for a population, the population summary measures are called parameters. So how we can calculate the population mean, that is denoted by mu. All the informations in the population data we have to consider. As how we are calculating the sample mean, X bar, similar formula we have to apply, but here the population size we have to consider. N is the number of observations, capital N denoted by, that is number of observations in the population. For X bar, summation of y is equal to 1 to n xi over small n. The small n denotes the sample size, how many observations in the sample. But for the population mean, that is denoted by mu, that is summation of xi divided by capital N. Here capital N denotes the population size or the number of observations in the population. So whatever numerical measure we are calculating for population, that is called as a parameters, right? Then population variance. This formula is little bit different, right? Now, can you identify what is the difference between the population variance and the sample variance? If you are answering, then you will have some bonus marks. Otherwise, today, only 150 participants are there, and you didn't make any answer for my question so far. So up to 7-5, who joined the meeting up to 6:35 considered for your attendance. Definitely, the Mahapola will be affected by this attendance, right? So up to 6:35, how much of students joined this meeting will be considered as the today class presence. Then from all other students will be marked as absence. Right. Now my question, what is the difference between the population variance and the sample variance? Only one small difference is there. You can observe with a formula with the two differences, right? What are in the notation, there are two differences. What are the differences? Put in the chat box. Five minutes time I am giving, right? Put your answer in the chat box. What is the difference between the population variance and the sample variance in the formula? Definitions and everything is same. The formula is different for both population variance and the sample variance. What is the difference you can observe? That's very good. The population variance is divided by capital N. The sample variance is divided by N minus 1. That is the major difference. In another difference, one more difference in the notation. For the sample variance and the population variance, one more difference is there. Yes, definitely. The population means and the sample mean. Here we are using the population mean, but here for the sample variance, we have to get the deviations from the sample mean. So mu and x bar. These both are differences in the population variance and the sample variance, right? So this is the way of studying statistics, right? So then only you can look at the formulas, and then in the proper way you can apply the formula. So such kind of observations are very important to get a proper understanding on the statistics subject. Then only you can apply properly the formulas, and also the proper interpretation you can make it, right? Then the population standard deviation, that is same as the sample standard deviation, but the formula is here different. we have to take the square root of the population variance, right? So this notation in the statistical inference, when we are studying, these notations often we will use, right? So this is also most commonly used measure of variations for population, shows variations about the mean. It is the square root of the population variance, and also it has the standard deviation has the original measurement unit as in the original data. Right. Now here one more thinking, general questions regarding the standard deviation, right? When we are calculating the standard deviation for sample observation, whether it will be affected by the outliers. Put answer yes or no. For calculating the standard deviation, whether the standard deviations will be affected by outliers. We already learned sample mean will be affected. The mean will be affected by the outliers. So the same questions here I am repeating that whether the standard deviation will be affected by outliers. Yes or no? Very simple question. Already we learned that the mean will be affected by the the mean will be affected by the extreme points, because all the values we are considering to calculate the mean value. Extreme values are located in the tails or left side of the end points of the data set. It may be left or right. So it will affect if there are few outliers are there, it will affected by the mean value will be affected by the outliers. Now, similarly, I am asking whether this standard deviation will be affected by the outliers. Yes or no? %68% of the data will be in the interval between mu minus sigma plus mu plus 1 sigma. That is, within one standard deviation, 68% of the data values will be mu plus 1 sigma and mu minus 1 sigma. Then for the 95% of the data will be fall within mu plus or minus 2 sigma, and 99.7% fall within mu plus minus 3 sigma. Then 0.3% will be considered as outliers, right? If the data is not distributed by the symmetrical or not a bell shaped, then this formula we have to apply, right? So 1 minus 1 over k squared into 100%. That is also put it here. You read and get the idea. Then interquartile range. This is very important because if there are outliers, then to summarize our results, we are taking the median value. If there are outliers, then as a measure of central tendency, to summarize the data, we are considering the median value. So similarly, if the outliers are there and we are summarizing the data by median value, then we cannot use range, and also we cannot use the standard deviation to identify the deviations from the mean. So in that case, we are using the interquartile range. Right? So interquartile range is given by third quartile minus first quartile. That is Q3 minus Q1. Now, what are the third quartile and the first quartile? So here, quartiles are dividing the data set into 4 equal parts. Mean value is dividing the data set into 2 equal parts, but the quartiles dividing the data set into 4 equal parts. So there are 3 quartiles: first quartile, second quartile, and the third quartile. The first quartile, 25% data, divided 25% and 75%. And the second quartile, that is same as median value, that is divides in the data set into 2 equal parts, 50% and 50%. Third quartile divides the data into 2 parts, 75% and the 25%. These are the positional measures, right? So this is the diagram representations of the quartiles. So minimum value, there are 12, right? There are only, we are taking the 5 observations, 12, 30, 45, 57, and 70. Minimum is 12, maximum is 70, right? Then the first quartile, 30, that is 25% and the 75%. And the median is 45, that is 50% and 50%. And the third quartile is 57, that is 75% and the 25%. So in the interquartile range is third quartile, 57 minus first quartile, 30, that is 27. Right? So within the interquartile range, 50% of the observations fall within the interquartile range. So what are the extreme points in the data set? They were eliminated. They are eliminated when we are calculating the quartile range. Only 50% of the data we are considering to calculate the interquartile range. Right? So what are the things? It is split the rank data. Here also we have to rank the data into 4 segments with an equal number of values per segment. Right? So this is the diagram. Here we are, and how we are interpreting those values also here. Right? How we are interpreting the median, the similar pattern for Q1. 25% of the data below or equal to Q1 and 75% of the data above or equal to Q1. Then for the Q2, as it is in the median, and for Q3, 75% of the data are equal to Q3 or below Q3, and 25% of the data are equal or above Q3, right? So how we can identify the position, right? So you have to take n plus 1 divided by 4. That is the position of the first quartile, and n plus 1 divided by 2 is the position of the second quartile, and 3 into n plus 1 divided by 4 is the position of the third quartile. Then on that position, what are the data value is located? That data value will be the first, second, third quartiles, right? So here n is the number of observed values. Now here, this is the example here. There are 9 observations. They are in the ordered array. So to identify the position of the first quartile, then we are taking 9 plus 1 divided by 4. That is 2.5 position of the rank data. So the first quartile is calculated by the average of second data and the third data. So 12 plus 13 divided by 2, that is 25.5. Right? So what is the interpretation of 20.5? 12.5, that is 25% of the data values are equal or below, and there, in this case, we don't need to use the 12.5 equal because it is in the midpoint. So 25% of the data are below 12.5 and 75% of the data values are above 12.5. Then Q2, that is the median. How we can calculate 9 plus 1 divided by 2. 10 divided by 2, that fifth position. So what is the fifth position? It is 16. Right? So median is 16. So 50% of the data values are equal to 16 or below 16. And 50% of the data values are equal to 16 or above 16. Similarly, the third quartile, so 9 plus 1 divided by 4 into 3. So that is 7.5. 7.5th position of the rank data. So 7.5 fifth position, it is, I think, an average of 18 plus 21. Right? And then that value will be as a third quartile. So now here you look at median is a measure of central tendency. That is represent the central location. Right? Median is a central location. But Q1 and Q2 are not non-central locations. Right? This is a difference between the Q1, Q3 and Q2. Q2 measures the central location, but Q1 and Q3 are the measuring the non-central location. Central locations means midpoint, but Q1 and Q3 are not midpoints of the data, right? So 12.5, 16 and the 19.5. How we are calculating. And also in the interpretations you have to look at. Then another main exploratory data analysis tool is box and whisker plot. This is also very important because when we are doing our your research methodology subject and the fourth year research, to get some insights regarding the variations of the data, you have to use the box and whisker plot. This is a graphical display. This graphical display is a summary. It's summarizing the data by using the 5 numbers. Right? It summarizes the data using the 5 numbers. One is the minimum and the first quartile, median, third quartile, and the maximum. Right? So here you have to calculate the minimum, identify the minimum value. What is the Q1 value? What is the median value? What is the third quartile value? What is the maximum value? Then by taking the scale as a horizontal line or the vertical line, both sides are okay. Usually we are taking the horizontal lines, but when we are using the statistical softwares to plot the graphs or even the vertical box plots also, we can plot it. So then you have to arrange the data values in the scales order, then mark the minimum value, then what will be your first value, first quartile, what will be the median, and what will be the maximum. These two endpoints are marking by the vertical lines. And then the first quartile and the third quartile and the median by the rectangle box, right? So the median will be the dividing the rectangular by the two parts. Right? So it is 25% data, here 25%, here 25%, 25%. This is the box plot. Now we look at how we can interpret or how we can get the insights about the variations of the data, even the measures of central tendency by using the median, how we can identify. Right? So now here, first we can identify the shape. By using this box and whisker plot, first we can identify the shape, whether data are symmetrical around the mean value. The box and central lines are centered between the endpoints if the data are symmetric around the mean value, right? If the data are symmetrical around the mean value, then the box and whisker plot are centered between the endpoints. Now here you look at, this is the median. So this line and this line are equally, both approximately same. Right? So exactly 25% data, you get here 25%, 25%. It's symmetrically divide, median symmetrically divides the two equal parts. This image is symmetrically identical mirror image to this part. So this line, this horizontal line is same as both right hand side and left hand side are same. And or even the rectangular diagram also symmetrically, both sides are equally divided. Right? So now if this is your shape of the box plot, then we can say that the data are symmetrically distributed. Right. Now we are looking at how the left skewed, the right skewed, and the symmetrical data with the box plots. And the distributional curve. Right? Now here looking at, this is the median value. Right? So if this line is larger than the right hand side part, then left tail is longer. Like it has a long left tail. So it is a left skewed. For symmetrical, the left hand side horizontal line is same as the right hand side horizontal line. So it is bell shaped curve or symmetrical. The curve is symmetrical. And when we are looking at this box plot, there the right tail is longer than the left tail. So if this is your diagram as a box and whisker plot, then we can say that it is a right skewed data. The data is distributed right skewed. Distributed as right skewed, right? Here you're looking at for the, we are drawing a box and whisker plot for the data. Here there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 observations are there. Then based on the definitions of the Q1, Q2, Q3, we are identifying 2 as Q1, 3 as Q2, 5 is Q3, and the minimum is 0 and the maximum is 27. So now here we are marking 0, here 27, then 2, that is your Q1, and 3, it is a Q2, and 5, it is Q3. Right now, you looking at your box and whisker plot. Here, the right tail is very long than the left tail. So, from this, we can say that the data are right skewed, right? Because this is longer than the left tail. So, the data are distributed as right skewed, right? And also, among the data, the variations also very high because this is the outlier. So, now here around middle 50% of the data is in between 2 to 5. That less variations, but because of this outlier, we are taking this longer right tail. Right? Now, what are the ethics we have to follow when we are using the descriptive measures? This is very important for you when you are applying statistical techniques to make right decisions regarding your managerial problem or your research, right? We have to ethically follow the rules or laws in the statistical analysis. First, you have to, what is the main objective of the data analysis? We have to report the summary measures that meet the assumptions about the data set. Based on the assumptions about the best assumptions of the data set, we have to report the summary measures. Actually, if your data are skewed, then definitely you have to report the median and the interquartile range, right? That is no harm. If your data is symmetrical, then you have to use mean and standard deviations to report the summary measure. Right? So according to the data pattern, you have to report your summary measures. Then data interpretation is subjective. That is, with a clear understanding of your terms, you have to make the interpretation. So it should be done in fair, neutral, and clear manner. You cannot write your interpretation as vague. Clearly, you have to put your words. Right? When you are writing your interpretation, easily we have to understand what are the things you are going to do, tell. And also, that should be in fair. That means you have to put your figures. Without figures, don't write your interpretation. Right? What are the actual figures you are getting? Suppose you are going to summarize your data using the mean and standard deviation. So what are the actual values you are get or you got? Use those measures to write your decision regarding your data. Right? So it should be done in fair, neutral, and in clear manner. Otherwise, it is a no use of using the statistical techniques to make decisions because decisions are very important. So mainly your data should be appropriate, right? You have to collect the real data, right? Then using your real data, what are the summary measures you are getting? You have to report those summary measures and then you have to write your decision by referencing or by citing your summary measures. You have to document both good and bad results. Suppose you are having some measures are good and some measures are bad. So don't ignore the bad results. You have to report that one. That is a main ethics, right? Then should be presented in fair, objective, and neutral manner. Should not use inappropriate summary measures to distort facts. Right? Like in the previous classes, we look at the graphical, how we have to make the good graphical presentations. We cannot distort our facts using the wrong measures, right? So you have to use appropriate summary measures without distorting the facts. Then this is the summary, mean, median, mode, and the geometric mean. From this, you have to get your questions. Then quartiles also you need, and describe measures of variations, range, interquartile range, variance, standard deviation, coefficient of variation, z-scores. Then to illustrate the shape of the distribution, one is the graphical dimension, symmetrical, then skewed, and the box and whisker plots. In addition to that, skewness coefficient and the kurtosis coefficient, that's two measures are reference. You have to find out from the appropriate reference materials. Right? Right. Right. Now you can have any questions regarding this chapter. If you have any doubts, you can ask now. Right. Now you put some comments regarding this numerical descriptive measures. What are the things you have understanding and what are the things you don't have understanding? And about my speed and my lectures and my notes. Put your comments on the chat box. To make some improvement on the next lectures. So your feedbacks are very important. And the time, morning 6:30, because the attendance are very poor. Right? So regarding this time, morning sessions, early morning 6:30 sessions, and the speed of lectures, and teaching about your understanding from my teaching, and the notes. Right. Now you MS 114, right? Where your chat box, right? One comment we got, please give more activity to improve, right? We can give more activity to improve. Now I ask one question, right? In the first question regarding the coefficient of, what the question I asked? The practical exercise one, right? Comparing the stock prices, right? Never one answer it. MS 114 also there. MS 114. Can you unmute your mic? MS 114. Now you look at, this is your response. So if you are responding in like that manner, what is the use of giving the more activities? That if you want to involve in the class activities, you also have some discussions, or you have to interact with me. Right? The two questions I asked, how you make your selections regarding the whether stock A or stock B. No one answered. So if you want to involve, or if you want to interact, or if you want to improve yourself, then definitely you have to interact. Right? So, and also the time, within the 45 hours, we have to complete it. Only 1 or 2 examples we can do in the class. Right? Other things, because based on the current teaching practices, it is a student-centered teaching. We have to do it. Right? Within 2 hours time, we have to, what are the things we are able to do? We can do it. Right? And also, only 1 or 2 examples we will give it. And if you want to interact more, you have to make interactions during the class session. Right? Otherwise, there is no use of. Right. Other comments regarding the morning session time. Now you look at only around 150 students are there. Right. Speed actually, if is it more difficult? My speed is more speed, or that according to the time frame, actually, some of the lectures we have to go fast. So if you want to get more understanding, what you have to do before coming to the lectures, the previous lectures, you have to be clear. Right? The previous lectures, you have to be clear. Then only what I am saying, you have to get clear understanding with my words. Right. Only some other more comments I am expecting. Right. So then I will justify why I am doing such kind of things. Right. Right. Now I am giving some comments regarding how you have to study the statistics. Right. First, you have to put your, now 3 chapters we completed. Right. For all, each and every student, now I am giving as a take-home assignment. Right. And the 1 week time will be given to you. You have to prepare a mind map. Right. Identify. If I think some of the students know the idea about the mind mapping, right? Otherwise, you have to search what is the mind mapping for the statistics subject. You have to build a mind map diagram starting from chapter 1, chapter 2, and chapter 3 in 1 page. In 1 A4 page, you have to build a mind mapping diagram for each and every student assignment, right? Build a mind map diagram for the only 1 page. Connecting what are the things you learn in chapter 1, chapter 2, and chapter 3. That means introduction to business statistics and data, and second chapter, graphical description of the data, and the third one is the numerical measures of the data. Connecting all these chapter 1, chapter 2, and chapter 3, you have to build a mind map diagram. That mind map diagram, you have to submit you have to draw a diagram in by writing, right? By handwriting, you draw a diagram in a A4 page and then scan that with your registration number and the index number, right? And then take the scan or scan the document, and you have to upload that scanned document as a PDF document, scanned PDF document in the folder that will be created in your LMS. Today is a Tuesday. Next Tuesday, before mid 12 o'clock. Next Tuesday, before midnight 12 o'clock, you have to upload. Right? That is the one take-home assignment. You will get 5 marks for that mind map diagram. That is take home as a assignment. 5 marks for that take home assignment. That will be uploaded in the next Tuesday before midnight, 12 o'clock. Mind map diagram for 3 chapters in the 1 page. Right? If more than 1 page, then that will not be marked. Only 1 page diagram will be considered as your mind map diagram. And then your continuous assessment that will be conducted via LMS MCQs mostly, and one word answer MCQs and the right or wrong. That will be in the LMS. That will be next Wednesday. That is 18th of Wednesday. You have a quiz 1. Right? That also will be covered with 3 chapters. Introduction to business statistics and data, descriptive methods, under that graphical methods and the numerical methods. So Tuesday, 2 assessments are there. Before midnight, Tuesday, 17th, before midnight, you have to submit your take-home assignment, the mind map. And Wednesday, the time will be informed later. Your assessment will be there. Any clarifications regarding these 2 assignments? And also regarding the time, please put your time regarding 6:30 time. Whether are you happy with the 6:30 or not? Because morning 6:30, if there is a physical starting, I don't know whether it will start on next week or I don't know. I am not sure about it. If it is a physical, then your lectures time. Otherwise, if it's a online system, I think morning is a very, very good time. But I don't know why the attendance are very poor. I don't know. But if you feel it's very difficult for the morning time, early morning time, 6:30, then you can make some comments on it. Then we will think about it, whether we are going to have on 6:30 or on your scheduled time. Right. So your assessments, regarding your assessments, I think you are okay. So the 2 deadlines, after the deadlines, we will not mark it, right? And also the quiz folder also will be, the assignment folder also will be closed. So the assignment 1, that is regarding the mind map. So you have to prepare these 3 chapters for your exams. So when you are preparing your exams, similarly, the mind map also you have to build up, right? So that will easy to prepare your exams also. So the mind map, and then you have to be ready for your exam. So 5 marks for your mind map and 10 marks for your first assessment. So nearly 15 marks will be allocated for 10 to 15 marks will be allocated for the first assessment and the mind map. Right? It will range from 10 to 15, not exact 15, 10 to 15, it will range. Right. Any other things? So the next class, you will be informed later, right? Tomorrow you don't have lectures. So the next class will be informed later. Then we will start the new section, right? Probability and its distributions. Okay. So that will be informed later, right? So now I'm going to end my meeting. So get ready for the assessment exams. And also the next class, I think this Thursday or Friday or somewhat, it will start on the next week. So I will inform in advance when will be your next class. Right. Thank you for your attention.